Okay, this next section is for parallelograms. I'm going to try to hit the next two sections. We'll see if it works. So these rules are pretty simple. They're just here. So for quadrilateral, it'd be a parallelogram. Opposite sides have to be the same. So you have these congruency marks. You have them here, here. That means those opposite sides are the same. The other opposite sides are also the same. Then you also have angles that match when they're across from each other. So you have that here when they're across from each other. They have to be the same to be a parallelogram. With these consecutive angles like that, those have to add up to 180. And the math just works out when you do it this way. It's kind of the same number grouping. Those add up to 180 degrees. And then diagonals, whenever they're cut in the middle, then they're going to get split exactly in half. Now, this won't be congruent to this, but the other way it will work out. So let's get into these examples. So these are all parallelograms. Ooh, this one is a lot. Yeah, anyway, let's see what we can fit in here. So let's start here. So since they're parallelograms, we know that they're congruent. Oh, I didn't activate the marker. Okay, here we go. We know that these are congruent. So those red ones I'm going to set over here. 4x equals y. So here's an equation with two variables. You can't solve it. So let's just set that aside for now. These two are also going to be congruent. So let's do this one. X plus 18 equals 3x minus 2. So minus x, you'll have 18 equals 2x minus 2. Okay, I'm skipping steps. I did this. Minus x minus x. So 3x minus x is 2x. Then plus 2 plus 2, you get 20. This goes away. 20 equals 2x. Divided by 2, you get x equals 10. So x is 10. That means this little x right here is also 10. So that means this x is 10. I'm going to go back to the red one. So 4 times x, which is 10, equals y. So y equals 4 times 10 is 40. So there's your answers. Y equals 40, x equals 10. So right here and right here are the answers. Over here, we know these opposite sides are congruent. So let's start with that. 4x minus 3 equals y over 5. Okay, so again, you have an equation with two variables, and I can't do anything with that. So I'm just going to leave it there. We know these angles are congruent since they're across from each other. So 49 equals 4x minus 37. So I'm going to add 37 here. 49 plus 37 is 86. 86 equals 4x. 86 divided by 4. Oops, divided by 4 is... Okay, so that's just going to be 86 divided by 4 equals x, which reduces to 43 over 2. That's your x. There's not a lot of space on here right now. Sorry about that. Let's keep going. If you don't want to deal with this fraction, you can convert it to a decimal, but I'm just going to leave it as a fraction because it's not a big deal. Okay, so x is 43 over 2. So 4, and then 43 over 2 minus 3 equals y over 5. Let's simplify this side on the left first. 4 times 43 over 2 is 86. Hey, that works out nicely. So 86 minus 3 equals y over 5. So 83 equals y over 5, and then multiply both sides by 5. I'm sorry for the mess here. So 5 times 83 is 415. That's a big number. Okay, well, I think it's right. So y equals 415. Okay, so answers to 2 are this and this, 43 over 2. Alright, let's go to this one. So now you have these diagonals that are equal. So 2x plus 10 equals 4x minus 2. Hey, this one works. So subtract 2x, you get 10 equals 2x minus 2. Add 2, you get 12 equals 2x. And then 6 equals x. So that's x, that's a 6. Then for the other one, these are congruent to each other. So that's going to be 5y minus 16 equals 3y. So what I would do with this is subtract 5y. So negative 16 equals negative 2y. Because 3 minus 5 is negative 2. So then divide by negative 2, you get 8 equals y. Alright, that one was neater. Okay, so there's a lot of stuff here, but we're just going to work it out. PO is this line right here. This line is the same as this line here. So PO is 24 because they're the same. See how many colors I can use with this. OQ is this line right here. We know that this line is congruent to this line. So this is 14 also. NO is right here. NO is the same as this line over here. So it's 26. So NO equals 26. PQ is this line right here, which is the same as this line right here. So PQ is 20.7. 20.7 here. PMN, PMN. So now we're looking at angles. P, I'm going to go a different color. P is here, M is here, and N is here. Alright, so I need this angle right here. Well, we know that this is 59 down here, so this is also 59 here. We know that these have to add up to, okay, this whole thing is 68. So we know that that's 68 plus 59 plus whatever else has to equal 180. So 180 minus 59 minus 68. So that makes this angle in here 53. That's a 5, sorry. So 59 plus 53 is 112. So this angle here is 112. 112 degrees. NOP. That's going to be this angle down here. And we know it's the same as that other purple one. So it's also 112. Okay. Change to another color. It's getting real messy. OPM. So OPM. That's the same, that's this angle right here, which is the same as this angle here. So OPM is 68 degrees. NMO, okay, last one on here, NMO is NMO. It's right here. So we did this one earlier, it's 59 right there. So NMO is 59 degrees. Cool. I think that concludes this one. This one, 7.3, is still talking about parallelograms. That's a lot of it's still the same stuff. So this is proving that when things are parallelograms. So here you have this nice little table that has all your parallelogram rules. Okay, so we'll be referencing this little table here. So the first one, you have parallel lines and congruent lines. So that's number 4 here. Opposite sides, parallel, congruent. So that's what you put. Opposite sides, parallel, and congruent. Then number 2, that's going to be this third one here, parallelogram, opposite angles, converse. So opposite angles. Good enough. And here you have the diagonals. So that is called, it's right there. So that's the diagonals converse. Okay, so this is pretty much more of the same that we were doing before. We'll go ahead and work these just so you have some more examples. So here you have these two are consecutive, so they're going to be supplementary. So 3x minus 20 plus x plus 40 equals 180. So that's going to be 4x plus 20 equals 180. 4x equals 160. So x equals 40. Then same thing, well, you can do this other one differently. You can say that these two are equal. So x is 40. So 3 times 40 is 120. So 3 times x is 40 minus 20 equals 4y. So 120 minus 20 equals 4y. And then 100 equals 4y, which means 25 equals y. With this next one, you have diagonals being the same. So 2y equals y plus 1. Subtract a y, y equals 1. Then you have 6x equals 4x plus 10. 2x equals 10, and then x equals 5. These are pretty straightforward. Okay, I'm fixing to run out of time on this video, so I'm just going to set these up for you, and you can work them out. 10x plus 7 is the same as this side, 12x minus 9. And then you'll also do y equals 106. So those are the two equations here. Over here, top and bottom, you do these two. 70 equals 4y plus 2 is the first one. And the other one you do 5x plus 16 equals 6x minus 1. So this is the first step for these two. You'll do each of them basically just solve from here. Yeah, I'll post these notes completed on Canvas and on Google, so you'll be able to access the rest of this. But it's just like what we've been doing on this section. So yeah, that'll be it for parallelograms. There's one more video in this unit.